Hello everyone, I am Amit Singh. I am the research scholar from IIT Varanasi. Uh, I am here to give my presentation of one-dimensional consolidation considering a trapezoidal initial axis pore water pressure. These are the content, introduction, objective of study, numerical analysis, result and discussion, comparison, and conclusion. Uh, Introduction. Consolidation is the process in which expulsion of pore water pressure from clay layer takes place with the change in effective stress. Conventionally, the study of the consolidation is carried out by the one-dimensional consolidation equation of Tarjagis, and on application of the external load, an initial excess pore water pressure develops throughout the depth of the soil, and Tarjagi assumed that these initial excess pore water pressure throughout the depth is uniform throughout the depth. But this assumption is valid only if consolidation layer is very thin and contact area is very large, like tunnel, earthen dam, and etc. However, there are many structures uh, create non-uniform initial axis pore water pressure, like self-weight of slurry give initial axis pore water pressure, shallow foundation create linearly increasing, decreasing, trapezoidal, exponential decaying shape of initial axis pore water pressure depending upon the field condition. Many researchers, Singh and Swami, Lovisha, Janbo, work on non-uniform shape of initial access pore water pressure for pervious top, pervious bottom, and pervious top and impervious bottom boundary conditions. Here we take the two trapezoidal initial access pore water pressure distribution uh, for analysis. The reason behind to take trapezoidal shape of initial access pore water pressure distribution is that it is generated within the shallow foundation, and by changing the parameter like B1, B2, B3, we can convert it into the linearly increasing, linearly decreasing, as well as in uniform shape of uh, pore water pressure distribution. The equations by which we generate the uh, trapezoidal shape of these pore water pressure are given below. Numerical analysis. The analysis is done by the Tarjagi one-dimensional consolidation equation, and the analysis is done by the numerically implicit and explicit scheme of finite difference method. Explicit method is the conditionally stable method, and in which the value of lambda cannot be increased by zero point 0.5, and implicit method is the stable method. So, but the results on by the implicit and explicit method are overlap to each other. The impact of trapezoidal in, initial excess pore water pressure on the progress of consolidation phenomena are presented by the series of isochrone and consolidating curves. Here we take the eight different symmetric and asymmetric shape of pore water pressure for the analysis. Due to variation of initial excess pore water pressure, the isochrone are presented in the normalized form. Here in figure, the solid line represented the shape of initial excess pore water pressure, and the dotted line represented the different isochrone, and the dashed line represented the Umax path, which is the locus of the maximum point on the isochrone. Uh, the isochrone are drawn for four different time factors of zero point zero 0.02, zero point 0.06, zero point 0.1, and zero point 0.2. And from figure, we can observe that whatever be the shape of initial excess pore water pressure, the isochrone is converted in sinusoidal or parabolic shape after some time, and the UMAC path always going towards the midpoint and in-depth at the midpoint for pervious top and pervious bottom boundary condition. And, and for pervious top impervious boundary condition, we can observe that the Jumex pass in-depth at the bottom layer of the consolidating layer. And there are some redistribution of pore water pressure are also take place depending upon the shape of the pore water initial access pore water pressure. And the this is the slide which represents the settlement curve of the figure 1 represent for PTPB, and these two figures are represented the settlement curve for PTIB boundary condition. Uh, in For PTPB condition boundary condition, we can observe that if the sorter based on the x-axis will give the same settlement curve for all the cases. Uh, and For PTIB condition, all different shape given the different settlement curve. So from this figure, we can say that the isochrone alone cannot provide the whole information of the consolidation phenomena. Uh, and if we compare the trapezoidal shape of initial shape of pore water pressure from the uniform initial excess pore water pressure, we found that the dissipation of initial excess pore water pressure is high in case of trapezoidal shape initial excess pore water pressure for both PTPB and PTIB condition, and settlement is also be less in trapezoidal initial access pore water pressure. So, in field condition, if we assume the uniform initial access pore water pressure, then we over predict the settlement. Here is the comparison with the analytical result obtained by the Lovisa, and from figure it can be observed that the both numerical and analytical results are close to each other. And conclusion. So the analysis is suggested that the assumption of trapezoidal initial access pore water pressure faster in the process of the consolidation than the conventional uniform initial access pore water pressure, and the settlement is less with compared to the uniform initial access pore water pressure, and the isochrone alone cannot provide the idea of whole consolidation process. And these are the references. Thank you.